Assalamualaikum. For the presentation for Formative Assessment Week 2, our group will present about the concept and principle of pre-stressing, also the procedures of the pre-stress construction work, also discuss with facts the comparison between the conventional in-situ construction method and the precast concrete, also discuss how precast concrete construction can contribute towards reducing carbon dioxide and global warming issue. My name is HUSAINI bin ROSLI, and I will present about the concept of prestressing and the principle of prestressing. Concept of prestressing. The concept of prestressing has been applied years earlier, as metal bands were wrapped around wooden parts to shape containers. The idea of prestressing was developed. Tensile stress was applied to the metal bands, causing compression between the wooden staves and enabling them to withstand internal liquid pressure. Thus, the concept of prestressing is developed into the construction world, which is the prestressed concrete. When the beam is loaded, the pressure is felt at the bottom of the concrete. Since there is no tensile strength, the stress can induce the deformation and cracking at tension zone of concrete beam. Thus, steel is implemented as reinforcement in order to increase the tensile strength of concrete, which is known as reinforcement concrete structure. However, the crack still could happen when the beam span is greater and the external loading is also greater. Due to the weakness of the reinforcement concrete structure, the principle of prestressing is applied to the concrete structure, which is the tensile stress can increase when the tendons are stretched to their elastic maximum. After releasing the tendons, it will attempt to return to its initial state from its extended state. It cannot be returned to its original state owing to the locking of the tendons at the structure's end. It is constantly squeezing the framework along with itself, causing compressive stresses to form in that region. The beam structure can be deflected upwards when the lower section of the structure has higher compressive stresses. Following external loading, the sum of tensile stresses produced is reduced by the compressive stress developed in the structure due to the prestressing. There are two types of pre-stressed concrete. First is the pre-tensioning, second is the post-tensioning. If you look at the figure 1, pre-tensioning is a process of pre-stressing concrete under which the tendons are tensioned until the concrete is set. The pre-stress in this process is imparted to concrete by a connection between steel and concrete. Second is the post-tensioning, a method of pre-stressing concrete by tensioning the tendons against hardened concrete. In this method, the pre-stress is imparted to concrete by bearing.
Okay, next we go to the pre-stress construction work and the procedure. As we know, there have two methods of preparing pre-stressed concrete, which is the first one is pre-tension concrete and the second one is post-tension concrete. For the pre-tension concrete, the operation applied at a factory, the tendon is tensioned before pouring the concrete. The tendon has been cut after casting the concrete and the tendon is protected from corrosion and tension are transferred directly to concrete. For post-tension concrete, the operation are applied on site. The tendon is tensioned after the concrete pour and the tendon is placed after casting the concrete. So, here's the procedure.
Prestressed concrete is prepared by the two methods. First one is pre-tensioned concrete, and second one is post-tensioning concrete. Never be confused between the prestressed concrete and pre-tensioning concrete. because pre-tensioned is the method to prepare prestressed concrete. In pre-tensioned concrete, firstly steel wires are pulled, which will further act to produce compressive stress. After stretching of the steel wires, concreting is done. When concrete achieve its characteristic strength, then the grip of steel wires are removed. As we remove the wire grip, it tries to compress the concrete, which produce compressive stress in the bottom of beam. In post-tensioning concrete, a beam is casted firstly. During the casting, pipes are provided at the tension zone of the beam, which is at bottom for a simply supported beam. When concrete achieve its characteristic strength, then steel wires are inserted in these holes. Then these wires are stretched using hydraulic machines. After stretching, these wires are hauled up at the end and filled with the concrete. The principle of post-tensioning beam is same as the pre-tensioned beam.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is MEOR MEOR RAZALI. So I will continue on. The precast concrete is preferred compared to the conventional cast in situ in construction method. So this is the source from the website. So what is precast concrete? So the precast concrete, as we know, that it is poured and molded over rebar or wire, and then it will be cured off-site rather than the in situ concrete. The process is still the same, but the process happen on site, so it's different between these two. So why the precast concrete preferred than in situ cast concrete? The first, because of the quality control. Because precast concrete is mixed, poured and cured in a factory. Ideal condition and exacting measurement can be maintained throughout the process. So rather than the in situ cast concrete, in situ cast concrete will be having uncontrolled on the quality control, because of we cannot predict the environment, the weather, or any nature effect. So the next one is the labor efficiency. Precast concrete is much more labor efficient. This is because the work is done in a factory. The effort is maximized through the use of tools and machinery that simply isn't available on the job on site. The next one is the versatility. So as for the versatility, it is because of the factory-made precast concrete is shipped to such a wide range of customers for an equally varied range of application. The precast is in many ways more versatile than site cast concrete. A large variety of motif, colors, finishes are available, along with the smaller precast architecture element. The next one is the economies of scale. So because of the precast concrete use standard forms, slab can be mass produced, improving the economies of scale. So because of the precast concrete is factory made and standardized, there is a fixed pricing which enables you to accurately budget construction costs and avoid going over budget. Okay, moreover, the next one is the no on-site formwork. By eliminating logistical concern, the scheduling becomes easier, which is the in turns helps to ensure that the unexpected costs aren't accrued. So on-site formwork is a logistical headache. By using factory casting, you can avoid all the stress by coordinating on-site skill, labor, and logistics. So the last one is sustainable. By using the precast concrete, you will be maximizing material efficiency. Because of this precision of precast concrete, material waste is minimized. Concrete is a recyclable material, meaning you can build green efficiency into your precast concrete construction materials. That's it from me. Thank you.
Assalamualaikum and good day. My name is MUHD and ROSHISHAM. Now I'm going to present my part about precast concrete contributes toward reducing carbon dioxide in global warming. Before I go to my part, I would like to recap what is precast concrete. Precast concrete is a construction product produced by casting concrete in a reusable mold. It is produced in a controlled environment and then transported to the construction site and fed into place. So, does precast concrete contribute to reducing carbon dioxide in global warming? Yes, they are. Construction of precast concrete consumes lesser amount of concrete than in-situ concrete. It is found that volume of precast concrete is reduced by more than 50% than the in-situ casting. Reduce in concrete means that the cement usage also reduced. The lesser consumption of cement can lead to a 10% carbon reduction for a cubic meter of concrete. To conclude, more precast concrete used in construction, the lesser the carbon emission. Next, air quality is monitored and controlled. Since production of precast concrete is in a controlled environment, the production of dust from cement silos, fixtures operation, and sandblasting is minimized. This is where dust produced is controlled in a proper environment and not easily released to the air. Moreover, the unfit wood in the production plant will produce dust and is controlled by the EE. Precast concrete is found to be environmental friendly. The excess concrete was effectively used and the waste was crushed into a usable wood base known as a crusher run. Next, the steel inside the concrete was separated and recycled. All these points, concrete is able to absorb more than 40% of carbon over its structural life. Thus, because concrete can contribute towards reducing carbon dioxide and reduce global warming.
My name is Muhammad AMIRUL bin Abdul Rahim. So next, for the example of previous study, the history of precast concrete in Hong Kong can be dated back to mid-1980s, and it was mainly used in public residential buildings developed by the Hong Kong Housing Authority. It is found that the carbon emission of the studied residential apartment is about 669 kg carbon dioxide, equivalent per 1 square meter floor area. Precasting can lead to 10% carbon reduction for 1 cubic meter concrete. In Hong Kong, the public and private residential housing both hold about 50% population. In the private sector, the precast components are generally tailor-made for a specific building design and specific site. On the contrary, standardization across building projects is mostly adopted in public housing projects. Over the years, precast concrete has become more prevalent in terms of precasting percentage and the types of precast element, while it has only been introduced to private sector in the last decade. Based on the research finding, it is highly recommended to adopt precast concrete in building construction. The building industry should consider the carbon reduction as a benefit of implementing precast concrete. So next is for the statistic for this research. The chart show the percentage of carbon reduction against the precast concrete percentage used. According to the result, based on the 4 sets of scenario, adoption of precast concrete can lead to carbon reduction as compared with cast in situ concrete. The chart gives the influence of precast concrete percentage on carbon reduction. It is observed that with more precast concrete adopted, the carbon reduction percentage become larger. The precast concrete apartment only accounts for 3% of the total weight in apartment A/H, and the reduction percentage is 0.31%. On the contrary, for the scenario of 1 meter cube concrete, the precast weight percentage is 94%, resulting in much larger reduction percentage of 10%. The correlation between precast percentage and carbon reduction percentage reveals that adoption of more precast concrete in residential building project can reduce more carbon emission. Thank you. That's all from our presentation.